Hey everyone, this is Dan at SPE Motorsport. On this week's product spotlight, we're going to go over our Generation 2 Strike turbochargers. They're the 15 and up style turbos for the 6.7 Power Stroke. So we already have a first generation of these turbos out, and we made a few changes to them, mainly because we developed a whole new version that's going to be obviously different than the current versions. It's larger, and we're going to go over some of the internals and the design features and why we did it in this video, and all the ins and outs of them. Obviously you can see the covers are different. The main reason we went to a different casting on the covers is obviously we went to a larger compressor wheel. So one of the things that plagues these turbos in their design is, from the factory, it's a really solid turbo and they support a decent amount of power. But once you go beyond that and you want to increase the compressor wheel size, one of the issues that you run into is what is called surge line. And surge line is basically a ratio between the compressor side of the turbo and the turbine side of the turbo. And what happens is, if you put too large of a compressor wheel on it, on the turbo, and don't have an adequate turbine to drive it, you'll get surging, and it can happen at low RPMs. It can happen at times that you don't want it to happen. And that's one reason why on our stage 1 unit, which is to my left here, is only a 62 millimeter, because we're utilizing the factory turbine. And this is what I consider a square turbo, meaning you have a 62 inducer and a 62 exducer on the turbine side. And that's about the max ratio you really want to go with on this particular VGT turbo. So that's why that would be our stage 1 unit. Compared to what we have on the market now for the stage 1, obviously we have the different compressor cover on this one as well, carried over from the modified one here on my right. The reason we redid it is obviously, like I said, the larger compressor wheel, and we wanted to change the AR ratio. So the AR ratio on the compressor housing is actually different than factory on the compressor and the turbine housing, which required casting changes and a lot of other things that we had to work on. And with our knowledge and everything that we've already been doing for the last few years with turbos, we applied a lot of what we've learned and a lot of what we know these trucks like to kind of build a great step up in performance beyond where we're leaving off on the stage 1. So this turbocharger is a 66 inducer on the compressor, 66 millimeter inducer, and then on the turbine side is where we really did a lot of the work. As I was saying with the whole surge line thing, being that we went so large on the compressor side, we really had to work hard on the turbine side so that we didn't have any surging issues or drivability problems or anything like that. Because this turbocharger is produced to support up to 750 horsepower. And we will actually be testing the limits of this turbo here very, very shortly. The drivability portions and everything else is done with it, but we want to see how far we can actually go with it. All right, so on the turbine side of our GT37, our stage 2, as I stated before, I like to keep a 1-to-1 ratio on the inlet of the compressor and the outlet or the exducer of the turbine. So on our stage 1, it's 1-to-1. On our stage 2, it is also square and 1-to-1. So we have a 66 millimeter inducer on the compressor, a 66 millimeter exducer on the turbine. And that's obviously, you know, getting into the turbine and some of the stuff that we do differently through the years that we've learned, especially on modifying turbos. One of the things that's highly overlooked is the AR ratio of the turbine housing and or the compressor housing. So the AR is essentially the volume inside of the turbine housing or inside of the housing itself. So whenever you're increasing the size of the turbine itself to attain maximum capability out of the turbine, you're going to also need to increase the housing size. Now, you may say, all right, you can keep the housing smaller and help it spool quicker, et cetera, et cetera. It can, but then you also run into back pressure issues. And everybody knows VGT turbos, it's one of the things that's very hard to get away from with a modified version, is you're going to have back pressure. You pour more fuel to these trucks, you make more power, you're flowing more through the turbo in every aspect, turbine and compressor side. You're going to have to deal with back pressure. So essentially, these turbos aren't even modified turbos. We re-engineered our Stage 2 GT37 is pretty much completely re-engineered. So some of the modified turbos on the market, they'll have a 6-liter turbine. They'll put them in a stock style housing, stock AR ratio. We obviously have seen a few issues with that, and we have an understanding of why not to do that. And we developed our own turbine. So we went from on our Stage 2, we went from the stock turbine, which was a 71 inducer, to a 62 exducer, and we bumped it all the way up to a 75-66. So as far as we know, it's one of the largest on the market, and it should support quite a bit of power. So we're going to be, as time goes on here, we're going to be really pushing this turbo pretty hard. We have no reason, there's no reason we can't believe it would do 750 or more. So very capable, a very solid option if you're going to be running any additional fueling, whether it's a more aggressive pump, it could be a stroker pump, dual fueler, whatever it may be, or a slightly larger injector even, or the combination, whatever. But the Stage 2, I think, is going to cover some of the people that want to go a little bit beyond and still keep, the ability to tow and the drivability and everything that you want out of a factory engine or a factory truck, so to speak. So I think we kind of covered a lot of the major things and differences with the Stage 2. As I said, the turbine was a big feat for us, and it is a 10-blade style turbine, so it does have that cool sound. I can put a clip in here for you. And obviously, the other thing, obviously, other than just the turbine, is obviously the compressor wheel is larger. So the compressor wheel, as I stated, is a 66 inducer. And the other thing you'll notice that's a little bit different with our turbochargers is they are a through bore style compressor. So that means the turbine shaft is actually longer. If you look at if you actually look at our Stage 1. Our Stage 1 turbo, you can kind of see that the nut is essentially machined into the compressor wheel. So the compressor wheel itself is actually threaded, and the shaft only goes into the rear of the compressor wheel about 1 inch, which this is factory style. So our Stage 1 being that we're using a factory style turbine, we're going to utilize a factory style compressor wheel. So that's one of the major things, to point out. That's one of the major differences between the Stage 1 and the Stage 2 on my right here. So on the Stage 2, you'll see it's a through bore style compressor wheel. So our turbine, we actually extend the shaft the whole way through the compressor wheel. So the turbine's almost 3 inches, probably 2.5 to almost 3 inches longer than the factory one. And what this does is it supports the compressor wheel better, because you have more shaft. And obviously, if you're doing that, supporting it better, it allows us to actually give a better balance on the turbocharger, because if you think of it this way, the compressor wheel hanging off the front of the turbine, if you're just threading it into the back of the compressor wheel and you're spinning this really fast, you have a lot more of this possibility going on, a lot more angle, a lot more force that's able to actually twist. And you have to remember the compressor wheel is aluminum. So by running the shaft the whole way through the compressor wheel, you have a lot less deflection hanging off the end of the turbine shaft. So therefore you can spin this harder, it balances better, and it basically allows for just a complete better package. The other thing that I wanted to touch on with our turbochargers is whether it's the stage 1 or the stage 2, whichever one you go with, we have 360-degree thrust bearings. So the thrust bearing and the journal bearing package in these turbos, it's a 360-degree ring essentially. So in a standard turbo, you're only going to have around 270 degrees of thrust bearing. And what the thrust bearing deals with, it's your axial load. So it's your in and out load on your turbo. So as you start creating boost pressure and you start creating exhaust pressure, it's constantly pushing and pulling on that shaft. So right behind the compressor wheel, there's a washer, and that washer sits against the thrust bearing. And the thrust bearing is essentially what's keeping all that flat and dealing with that axial load. So any more surface area that you can add to that, once again, also helps with the longevity of the turbocharger and its general functionality. All right, so now that we've kind of gone over everything as far as the differences between our stage 1 and stage 2 on our generation 2 Strike turbos, I also wanted to touch base on these are a 15 and up style turbo, so 15 to 19. And we do offer retrofit kits if you want to put this on, say, a 16 or well, it'll be a 2014 and down truck. We do offer retrofit kits for it to help you out with that. So the VGT style turbos have a more stock drivability to them. So if you're towing or running them hard, either way, it's going to have a stock characteristic to it and how they react, which some people obviously want to retain. All right, so now that we kind of went over the ins and out of our stage 2 and stage 1 generation 2 Strike turbos, we're super excited to get them out on the market. We've been working on the stage 2 model. We've actually been working on for almost 2 years. So we're really pumped to get it. We're really pumped to get it finished and get it out there to the customers so that they can see how great they are. And I think everybody's going to be really happy with the product. So if you have any questions, you can email us, give us a call, let us know what you think. We'd be more than happy to help you any way we can. And we will catch you on the next one. Thanks.